this lecture I'm going to start to talk about how to evaluate an integral numerically. Now both the methods I'm going to do you will have seen before already, so I'm going to run quickly through the actual methods and a couple of examples, and then do a little bit of calculus and analysis on the results of these. Well, first of all, I've got a picture on the board of a curve y is equal to fx. Now I want to find a numerical way of evaluating x0 to x, the integral from x0 to x1 of fx dx. Now doing an integral numerically is often called quadrature. You sometimes see that in some of the old textbooks. Now what does it really mean when I want to evaluate that integral? It means I want to find the area under the curve y is equal to fx. Now that means in this picture that I really want to find the area including this little hump at the top, all this area here. But what we do is to say that it's approximately equal to the area of the trapezium, which I'll label A, B, P, Q, like that. This trapezium here. Now I've drawn a grossly exaggerated picture there. It looks as though we're making quite a large error here. Now the area of the trapezium is, from schoolwork, it's a half the base, like that. Well, it's the base times the mean of the two heights. Now the height here is y1 and the height here is y0, so it's y0 plus y1 over 2, like that. Now x1 minus x0, as we've seen before, is usually written as h, and so we've got h over 2 times y0 plus y1, or if you like the alternative notation, f0 plus f1. They both mean the same thing. Now that's a very simple formula, and I know you've all seen it before, and it's called the trapezoidal rule. Or sometimes just the trap rule for short. But it's just a simple geometric conception here. Well, now that's all right if the x0 and the x1 are fairly close together. If they start to get very wide apart, then just one application of this rule is obviously going to be rather inaccurate. So on the board over here, I've got what we do about a wider range. We want to integrate fx from a to b, like that. What we do is if this is a, like that, and this is b, these 2 points, we divide it into n strips, each of width a, h, like that, so that n times h is equal to b minus a from here to here. Each one of these widths here is h. Now the total integral in going from there to there is, the total integral is from a to b, and we split this up into the integral from x0 to x1. Remember that a is the same as x0, plus the integral from x1 to x2, plus, and all of them until we get up to the last one. And we simply apply the trapezoidal rule to each one of these individually, and this boils down to, well, for this one it's h over 2 f0 plus f1, and for this one it's h over 2 f1 plus f2, plus, and then finally h over 2 times f